Okay. Okay. So in this particular stream or recording, I want to continue some experimentation with the image library similar to last time. So last time we used a QOI image file decoder that we wrote from scratch to import a bitmap image that we exported. I don't need to bring it up. Basically, an image that had 1, 2, 3, 4 in it. We then imported all of these as individual pixels and then got them rendering. So I want to just experiment around with some of Raylib's native image kind of stuff, not their image importer. We've had problems with that before, but it's also worked before. But rather their functions for generating textures, I'll put it this way, generating textures and other things. But given that we already have an array of, by doing stuff manually, we very much have an array of pixels that we have complete control over. I want to now just like use this, I want to use this manual control in conjunction with Raylib's texture stuff to try and perhaps render this as a texture that might be easier to deal with. Okay, so like in previous apps, for example, like in the, there was no need for me to move that. In like the butterfly app, which we built, like with this one here, we just had a bunch of image files, and then we imported those as, I mean, I can bring up the code. We imported them, and then we immediately converted them to textures. In the current app, we'll be able to bypass part of this, but if I do, like, go down to, this is basically the code that once we actually had the, okay, if I zoom out a bit, I move these across. Like, this is the code that basically got this happening. We just loaded one of the images from memory, and then we immediately loaded it as a texture. Given that we've basically replaced this function here with our own, I do want to just investigate how we can manipulate the image before we convert it to a texture. Because in terms of design-wise, I would like I want to try out making a kind of like pixelated feel to this Sudoku app. It's been done like a bajillion times, but like often when it's done, there's still some weird artifacts. Like you might have some game that looks retro, but then the font is slightly blurry, and I think that's because of bitmap sizing issues and stuff. Anyway. Yeah, so in particular, all that in mind, I just want to investigate some of these kind of image drawing functions. All of these ones occur like on the CPU, and so I want to see what I want to kind of just explore what these functions do in Raylib. If they're good, we can use them. If they're lacking in some way, we can just write our own before we end up converting all of these numbers to textures. I should also note that at the moment we're just like we're reading in the entire image file and then immediately converting everything to individual pixels. Later on in some time we will need to chop this file up into just like 4 different parts, and so that's kind of why I want to investigate these as well. It would be great if, given our raw array of pixels, I can just say create 4 of these kind of like images separately, convert each of those into textures, and then start drawing all of these icons with that texture. for me, that's a conceptually easier way to approach this than like creating some gigantic texture and then trying to say, okay, like zoom into this corner of the texture. That being said, even that approach wouldn't be too bad since we really just have 4 textures here, so we could literally do things on a quadrant way, but that's not kind of sustainable in most cases. In most cases, when you're like wanting to zoom in on different parts of a texture, there's not 4 different parts that you're zooming in that have bilateral and that have like, you know, quadrilateral symmetry everywhere. Okay. Yep, so let's begin by like jumping into the code of some of these in the Raylib library and seeing what they do. We've at least got some summaries here. Okay, so this one here is already like quite useful, since this would enable us to just set up just like a square texture, which we're going to represent, say, the number 1 on its own and then just copy over pixels from our imported buffer into this. I'm not sure what this vector version is doing. We don't really need to do that. Yeah, drawing these circles, we can ignore that. Drawing rectangles. This itself could be useful actually. This would enable us to, so in a similar way that we've just drawn the individual pixels here with rectangles, we could try doing something similar here. Probably not this one. Okay. And then, okay, so we'll do some stuff with that and then we'll convert it to a texture as usual from this kind of thing. Okay. So let's jump into this then. Yeah, so let's figure out where these functions are in Raylib. So let's look up. I do want to try using this one immediately. This image draw rectangle function. Image draw rectangle. rtextures.c. Okay, here it is. I'm not sure what like this compressed image formats are, given that the image itself was, from memory, was something somewhat simple, but still a bit complicated. Like not as simple as just a literal array of pixels. Where's this defined again? Raylib.h 252. Yeah, so this is the struct and the functions that I want to just see. I want to just explore within Raylib. So yeah, some data, not exactly sure what Raylib's doing in this format, which is also why we did the QRI detour. I tried very briefly looking into this, it was confusing, and so I thought, great, the perfect excuse for me to learn QRI. curious that they're already doing bitmaps in this, and data format, pixel format type. Okay, whatever that is. So how long is this function? Security check to avoid program crash. Okay. Oh, so I guess these must be the different formats that for this part here. It's like uncompressed grayscale, uncompressed gray alpha. Don't know what R5 G6 B5 is, but okay. Something like this looks more familiar. Whoa, this is... And note, right, because this is in C and not Zig, you have to have these like breaks after every thing in a case. It is a... C did not get everything right. Okay. Yeah, so that's... It's like... Okay. That's what we, that does what we... Well, this does what we predicted. It just... colors a single pixel. Okay. What about the image draw a rectangle? Oh, okay. I'm just calling this one. Why is Emacs like stuttering like this? I don't understand. Well, something is off. Come on. Okay. A lot shorter than the previous one. Yeah, make sure all of the data is fine. Okay. And then, what's the actual drawing do? Fill in the first pixel with the first row based on the image format. Memory copy. Okay, so at least this is this isn't doing it in the crudest way of literally coloring in everything individually. Okay. Okay, yeah, let's start playing around with this. Okay. Since we already have the struct, we could probably initialize something like this ourselves. Maybe there's some easier way to do it. There's image copy, image from image. Is there an image in it? So yeah, all of these are just loading. Image generation function. Oh great, this is I think this is the one we want to begin with. Okay. So yeah, gen image color. Oh yeah. Oh yeah, okay, so this is how it's going to do it. So yeah, just make some space for it and then manually set everything to be the same. Oh, okay, that's... Maybe this is the fastest way to do it. Okay. Okay, let's roll with it. No, just... Okay, let's close the butterfly quiz one. So yeah, we don't want to be creating any of this stuff in. We want to set all of this up before the first loop, before the main game loop. So let's try this. Let's try this here. Actually, we want to load this first, and then I'm going to try this here. Create a Raylib.image or rather create images to hold the from which to generate the textures containing the numerals, the symbols, containing the bitmap numerals in the game. Okay. So we want to say Raylib, a variable, Raylib.image, called, we'll call it test for now, test I, is equal to Raylib.gen image color. Let's make this say 100 by 100, and then we need a Raylib.color. So why don't we just do... Debug won't work because we're defining our own colors. At least I'm pretty sure. Oh, maybe we actually can use these. What does RLC do again? Oh, we're returning a Raylib color. Great. So we can actually use these. This is totally fine. Okay, so we've generated this, and then to do resize, draw the not resize. We want to transfer the information. Bitmap info onto test I. And then once we've transferred that, we're then going to convert it into a texture. And then we're going to draw stuff with that texture. That will Raylib will do the OpenGL stuff behind the scenes necessary to set up the texture objects, the buffers, etc., push those to the GPU. Eventually, when we start doing stuff with Vulkan, and even further after that, DirectX, Direct 12, whatever the version number is, we'll be handling that stuff ourselves, but for the moment, we will push on. So yeah, what is the function we want? This one here, I think. Load texture from image. Load texture from image. So then we can say, presumably, the type of this is fine. So why don't we say a test I texture is equal to raylib.load texture from image, and then just test I. Yeah, it doesn't look like we don't need to take a pointer, we can just send it in. Okay. And then once we've done that, let's draw that. Our particular render screen is not going to have this in scope. So we better make space for this somehow. Should we define this as a global and then like we could, yeah, why not? We're going to be calling these, this is not what we wanted. We're going to be calling these at a couple of other places, so it's fine. Globals. We'll call this textures. Move this over here. That one. And yeah, what should we call this? Now we actually need to say what the type of this is. So this is just returning a texture 2D. Okay. Texture 2D, and the pointer to it will be assigned over here. Now we want to say test I texture, create memory, set this to the pointer. Okay, now let's actually use this in our render functions. And why don't we just draw this in the first screen that happens. What's the function again? We want to say, right. When we worked on the Butterfly app, we found that when these images are drawn in the usual Raylib way, the position you point in is where like the top left of it starts from. But we want to do everything centered. So let's just copy the code from the last app we developed that did that. So I think it was called like draw text. No. What about draw photo? Draw image? Okay, what about just draw underscore? Oh, draw border texture. I guess this is what we want. Yeah, we will adapt this. Let's move this down here. And then, what do we want to do? Yeah, this is taking a pointer to the texture, a center position, a height. Oh, we're going to be scaling it as well. Let's kind of ignore the bordered part now and actually just do the position and the height. So yeah, so we get those things, scale ratio. The final height we want is the one we specify. So then we need to scale the width accordingly. And then we have to deal with Raylib vectors, go figure. What's this third argument 0 is for rotation? What does this even mean? It can't really be that. That doesn't look like the third argument to me. Is it this one? Okay. That's a more sensible place to do that. And we're not doing any scaled rect since this is no longer a bordered thing. Why do we need to specify white if we're drawing a texture? Okay. Hopefully this works. Actually, before, let's copy this. Okay. So now let's draw the test eye texture. So we want this to be, oh, we needed a pointer. So let's take the pointer of test eye texture. Yep. And then the position. Let's draw this, let's say the center of the screen. Why don't we actually, let's draw this at say like 200 and 200. And then we'll make the height kind of small. Let's make it like 50. What is Emacs doing? Get out of here. Good. Okay. Let's give this, hey two-step. Yeah, we're gonna see now how it's going. I'm not expecting this to compile without an error. I mean, it's not going to compile if there's an error. And there is one. Okay. 165. What? Expected. Oh. What's this error? Expected type, blah, 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 image found comp time int. Oh, yeah. Wait, what? What? Do we really need to say to Raylib like treat these as U32s? I mean, I guess. Let's just try. Say like num1 of type U32 is 100, and then if it's an int, it's going to be an I32, and then n1. Nope, doesn't like that. What am I failing to do in this? we've specified the width and the height, and then the color. Yeah, image is a struct. Image is the following struct. I mean, and we can look up this get image color again, but it was like our textures.c, right? Oh, well, I'm calling the wrong function. Okay, oops. No, I'm not. Wait, what am I talking about? This is an image generated. Wait, what? Why? Wait, what's happening? This is a function that's meant to be returning an image, and yet the comment here is get image pixel color at XY. Like, what's that talking about? Yeah, this isn't... What? Oh, who would name two functions that differ in a single letter? Like, I guess, I get that I'm being really silly by not realizing the letter T is the letter N, but they are so similar. Like, get image color and gen image color. Like, this is totally my fault, but at the same time, I want to absolve myself of this sin. But thank you again. Two-step. Okay. Yeah. Look, it's late at night. I'm just. It's gonna be a while before I admit that was actually a mistake on my part. Okay. Okay, so maybe actually I can now just ignore this and go back to having 100s here and not have it complain that it's comp time. Or we'll just go back to. This is a different error. Okay. 2, 3, 4. I'm not allowed to use the. Since this isn't my function, but the Raylibs, I can't use this standard vec2. I have to do like this Raylib vector format. So what is it? It's like Raylib dot like this thing. It's so annoying. I kind of want to just write a function now that converts vec2 to Raylib, and then I don't have to. Everything can be vec2. So why don't we do function vec2 to Raylib? and it will just take something in vec2 and it will output raylib dot vec2 and I should just be able to copy this. And then we're going to return this dumb thing, and it's literally just like vec0 and vec1. That's all it should be. And then, okay, now we've got that. What was this error? It was like 2, 5, 2, 3, 4. I can now say vec2 to raylib vec2. Okay. Okay, why is this one erroring? Oh, okay, I was this is what happens late at night. I thought I was calling a Raylib function, but apparently I was calling my own. Yeah, okay. Okay, well then what was the error? What on earth was wrong with this then? Why was this... What was failing? Like what? Okay, so two set stairs, did you declare the vec2 struct? If so, maybe make that a member function so you could do that to that. Yeah. I can't, later on I will practice this like member function stuff with Zig. I do want to go to bed in the next like 20 minutes, so let me just get this working and then I'll try and do this next time. I just want to draw this texture and then we'll be good to go. This error can be expressed by assigning the value to something. Oh, I see. I'm actually returning... What am I returning from this? I'm returning the scaled height. Okay, so why don't we just say... Maybe I say that then. Aha, and it's working. There it is. Okay. Okay, I lied when I said I'm happy to go to bed now. I want to do more. Let's do more. Okay. First of all, let's save what we've done. So what's changed? Oh, I think last stream I said I wanted to clean this up, and then I was too tired and I didn't. I don't want to I don't want to repeat that same mistake. This is too much to look at. How have I changed qi.zig? Okay, and then how have I changed the main one? In the all of those, okay. Yeah, started using raylib.image structs to create textures with more control. Okay. So yeah, let's clean up let's clean up so much of the stuff in here. I don't want to just blanket force delete everything in here, because some of this might be useful. What's a good way to go about this? Because I feel like some of the stuff like the bitmap glyph offsets we do need, and okay, let's just literally go through this one by one. But actually, before I do that, we should just make a separate folder for the actual bitmap stuff that we're using. Since I haven't really done that so far. Okay. New folder, bitmap files. Well, that's obvious. Just, let's call it like bitmap stuff. Okay. Where's the file when we read the bitlab? Okay. We're actually reading something from QII tests, so we should probably move that. QI tests. We should leave stuff in here. But let's copy this one. 8514 bitmap QII to bitmap stuff. Okay. Let's replace this. Bitmap stuff. Okay. Looking at this list again, what do we want to keep? No, 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 no. No, 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 no. We've already saved that now. No, no. We want to save this bitmap glyphs offset. Okay. Let's just first of all save the bitmap stuff we did. Then we want to save bitmap glyph. I think we want to save this. Like we're gonna need this stuff when we start converting each of the like individual numerals to separate image stuff. We can just generate this again, but why do that when we can just save it now? We do want to save this one. Well, maybe we actually want to resave that, because I can't remember if I saved it last time. So this is the stuff we were using, and I guess we want to save configuration as why don't we call this like bitmap options that work, or maybe just bitmap options for this file, which was, what was it called, like 85. Why is there more than one main? No, it's so annoying. No, I don't want this. Close. Okay, 8514 is what we want this. Okay. Save configuration as bitmap options 28514. Okay, let's add that to it. Options. What's this bitmap.txt? This was what we made in a moment of weakness when making this is what made us decide to write our own decoder. That was how bad things got. We can keep this as a memento. Okay. This connection 2 stuff, whatever. Yeah, I think we can delete the rest. So yeah, saving what we need, the offsets, the options, and that stuff. And we also want this one too. Okay. Saved some bitmap stuff and some main changes. Okay. Okay, so now before I force delete it, let's just look through the list again. So yep. Yeah, that's fine. Yep. Okay, so what is it? It's like git clean xn, tells us what would get removed. And then, yeah, let's just delete it all. Okay. But for some reason, it didn't delete it all. Why? What's this connection to? No, we're not using this font anymore. Delete. Larceny is going as is. Is this fix 01? No. I'm deleting this as well. Okay. Yeah, bitmap stuff. There it is. Here's the stuff we actually need when we did our tests. And then, great. I think, oh, we don't need this one here anymore. Since we've just copied that over here, right? We should move, we should move some of these around. Those should go in here. As should that. Yep, that looks good. Oh, okay. Okay. No need to procrastinate on that anymore. Okay. Yes. Okay. Okay, have you ever looked at the ppm format? Nice and oh yeah, ppm is super simple. I do like that for some applications. That was what I used when I made a ray tracer using the ray tracing from scratch in one weekend. Ray tracing in one weekend. Where's the book? Here it is. Yeah, this is like, in my opinion, this is the shortest, this is like the simplest way this is like the fastest way to learn how to make a ray tracer. You kind of just like read a section, understand the idea, ignore the code, and then just write your own code. And there's basically just like 14, there's like 13 ideas. There's actually, ray tracers don't have that, a really basic ray tracer like this doesn't actually have that many ideas in it. This is all to say that the very first thing you output in this series is this ppm format. And yeah, that's how I learned about that. Oh, cool. Yeah, nice. Yeah. I think as well, there's a couple of, there's many simple examples. I think the Wikipedia article for ppm has some examples which you can copy and work with. I think I copied one on stream a while ago and it didn't work, but at least one of them does. Okay, back to this test I. So yeah, let's do at least some of this bitmap stuff. So okay, so why don't we actually just, let's use this, using the bitmap we've imported, let's like double it in size and then store that doubled size as this test I and then draw that. And then it is late. I have 5 hours of teaching tomorrow and have to install software on my laptop before 9. Okay. We'll push this for next stream. We'll do this tomorrow night. Last thing, let's just do this draw like this rectangle in the image. What is it? Image draw rectangle, I think. Okay, let's just do this. So Raylib dot, and it's not returning anything, great. A pointer to the image, okay. Test I, the position that we want to draw within this image, so let's make it slightly larger then. 200 by 200. Let's draw this at, say, 50 and 50. Likewise, let's make this 50, let's make everything 50. And then let's choose a non-debug color. So what have we got? Why don't we do, okay, it doesn't matter, but like, we'll just use yellow. Using image draw. Okay, zig build run. Yeah, the ray tracing article I really enjoyed. I will be the first to say though that I absolutely could not do it in one weekend. Part of that was intentional. Part of it was I wanted to like read a section just to understand to get a glimpse of what the main idea was, and then go out and figure out the details of that main idea on my own, and then implement that. And I did find that process extremely enjoyable. Yeah, it wasn't for everyone, but I walked away from that experience having a really concrete application of some linear algebra I learned, So for instance, when you're drawing the like mirror balls, you have some ray coming in, and then you need to figure out how it's going to reflect. So the problem becomes like a linear algebra problem. Given some point on a sphere, and giving some incoming ray, how do you kind of reflect that? You can do this, like, I figured out how to do this with eigenvalues and eigenvectors, which was fun. But there's like a really simple way of doing it, and then I kind of did my way, compared it to the book, and it was basically the same in the book, and I was like, yes, I did all of this without needing to. I felt like I figured it out myself, which was fun. Okay, and yeah, I can. Okay, this is really tiny. I kind of want to actually make it a bit larger. Let's now make the size, the height of this texture, like that we're drawing, like 500. Make it large, and then I will call it a night. Okay, and also, yeah, I'm not seeing too much blurring going on with this, which I'm happy with. Let's make this even larger. Because if this is the case, then we can literally just copy over the individual pixels, and then when it scales, it will look really crisp. Great, yeah, I'm kind of happy with this. I want to do this crispy experiment though, which will take a couple minutes at most. Wait, where were we? Oh, here. Okay, so let's actually make this image like 5 by 5, and then when we're drawing a rectangle, what's the position and then the width and the height. Let's like draw this pixel at like 1 and 1, and make it like 2 by 2. Will this? Oh, great. It's been scaled, but I'm not seeing any ugly blurring happening. This bodes really well. Yeah, that's what we did. Used the rect image draw rect procedure. Texture scale. Well. Okay. Yeah, that is going to be it for tonight, folks. Thanks for joining. Thanks as usual to Steph for the company and help. And then yeah, hopefully tomorrow night, or definitely the night after, we'll get all of these numbers here onto these actual tiles, and then we can start playing around with like interactivity, figuring out when a puzzle has been solved, even just like declaring the data type for a puzzle, writing some comp time parser that will turn a text file with puzzle coordinates in, all of that kind of stuff. There is a long to-do list here, and why not make it slightly longer now? Create textures for the numbers 1 through to 4 using the bitmap. This is the main one that we're doing. Current thing. What did I do? Like current. Okay. I didn't add anything else. Okay. yeah, hopefully see everyone here next time. Okay, take care. Bye.